Good afternoon, friends. Welcome back to Parijat sir's classes. Today we will be discussing about some electricity chapter JEE sums. Today we will be doing sums from the JEE electricity. So follow the class. It's going to be very interesting today because I'll be showing you certain very good examples of certain JEE sums. So before that, I would like to request you, please subscribe my channel and press the bell icon so that you can get further notifications of my classes which are going to come. Okay, so let's not waste time and let's get started with some JEE sums which we'll be doing today about electricity. Okay, so let's get started. So first, I'll show you certain very good examples of electricity chapter which will be very helpful to you because I'll be showing you certain tricks. Okay, so let's get started. The first sum. So there is a circuit given like this. Today I will tell you certain tricks how to solve these sums because they are very difficult to analyze whether these circuit, the resistances connected, they are in series or in parallel. It's very difficult for us to know. So this is a circuit given where there is a 2 ohm resistance connected all along like this. So how to solve this sum? It's very difficult to find out whether this circuit is in the series or in the parallel connection. So let's see the trick behind it. First of all, you have to find out a line in the circuit where it can divide the whole diagram into 2 equal parts. So this is that line. So what we can see is that this is the line of the symmetry which can divide actually the whole circuit into 2 equal halves. So see, 2, 2, 2 and this is 2, 2, 2. So it's equally divided and 1 ohm and 1 ohm will be on this side. So it's a symmetrical circuit. So first of all, you have to find out a line which will be dividing it symmetrically. Now when you divide it symmetrically, all the points lying on the symmetrical line will have the same potential. That means this will be the same potential. This will be the same potential. So these 2 lines are in the same potential. So what we can do is that because they are in the same potential, so the current will not flow through this. So what we can do is that we can just remove this connection. We can remove the connection from here. So it becomes like this. So you see, get the point. So this is the circuit now. Now it becomes very easy to you. How is it? This is 2 and 2 is series. So 4 ohms with 2 ohms. So what is the ring? 1 plus 1 by 4 plus 1 by 2. So it's about 1 plus 2, 3 by 4. So it's 4 by 3 ohms. So this part is 4 by 3 ohms. So if I rub it and write here 4 by 3 ohms, the circuit will become very easy. So here it is. This is actually 4 by 3 ohms. So now it becomes very easy. 2 ohms, 4 by 3 and 2 ohms will be in series. So what is the net resistance? 2 plus 4 by 3 plus 2. So 4 plus 4 by 3. 4 plus 4 by 3, 12 plus 4, 16 by 3 ohms. So this whole arrangement is about 16 by 3 ohms. If I rub it and write here a resistance whose value is 16 by 3 ohms, so it will make the circuit quite easy. So this is 16 by 3 ohms. That means now my total resistance is very easy to calculate. And what is it? That is 4 ohms and 16 by 3 ohms are in parallel. So it will become 3 by 16 plus 1 by 4, which is 16, 3 plus 4, 7 by 16. That means my net equivalent resistance will be 16 by 7 ohms. And that is the answer. So this is how you are solving certain sums which are coming in the JEE nowadays. And it's very important to know the tricks. So let's see another sum. Please keep revising the videos so that you get the idea, because it's very difficult to just watch. So I would suggest you to keep watching the videos time and again. Another sum I'll discuss today is, this is a very important sum. So this is point O, this is A, this is B, this is C. So supposing this is, all the resistances are of the same value. They are R3, R1, R2. Current coming out is I1, I2 and I3. So they're asking that what is the potential at O? What is the potential at O? So we know, according to the Kirchhoff first law, the current coming and leaving a certain point should be equal. Sum of the currents leaving and coming at a certain point should be equal. So we can write from here, we can choose out from here, like I3 is coming out, I1 is, it's going out from this point. So if I take it the opposite, I will write minus I1, and if I take it the opposite direction, it will be minus I2. So what I am getting is that I1 plus I2 plus I3 is coming 0. Okay, we have applied Kirchhoff's first law. This is Kirchhoff's first law. First law. According to that, we are getting the total current coming into a point and total current going out should be equal. So according to that, we got this. Now watch here. In this case, now current is coming in this direction, so I will write this potential is higher, VO minus VA. VO minus VA will be I1 and R1. Okay. Similarly, in this case, VO minus VB will be I2 R2. Similarly, VO minus V3 VC will be I3 R3. So what is I1 from here? I1 will be VO minus VA by R1. I2 will be VO minus VB by R2, and I3 will be VO minus VC by R3. Now putting I1, I2 and I3 in this equation, what do we get? I1 is this, VO minus VA by R1 plus I2 is VO minus VB by R2 plus VO minus VC by R3 should be 0. Okay. So from here, what we can write is, let me rub out certain portion of it, so it will become easy for us. So let us rub out this portion, so it will be easy for us to write. So friends, see, I used Kirchhoff's first law, and then what I am doing is that, so this is I1, I2 and I3. So from there, we can find out VO is 1 by R1 plus 1 by R2 plus 1 by R3 is equal to VA by R1 plus VB by R2 plus VC by R3. So what is VO? VO will be this by this. So we can get it as VO will be VA by R1 plus VB by R2 plus VC by R3 divided by this. That means I can write 1 by R1 plus 1 by R2 plus 1 by R3 to the power minus 1. So if the values are known to you, you can easily put the values and calculate it. So that will be a quite better answer coming. So I hope you understood. Okay. Please watch it again so that you can watch the video again so that you can get the solution. Now today we will be discussing quite a few sums. So I would suggest my friends to be with me and keep looking how am I doing the numericals. Okay. So let's see one more sum. So here is a circuit given. So this is a circuit given here, and so I would suggest my friends to always try with me, because it will be better for you to learn. Keep trying with me. It is better for you to learn. So let's give the name A, and this is given the B, C, D, and this is given E, F, G, and this is H. So this is given 6 volt. In the numerical it's given 6 volt, and this is given 3 ohms. This is given 2 ohms. This is given 2 ohms. This is given 4 ohms. This is 8 ohms. 8 ohms. This is 2 ohms. This is 2 ohms, and this is given 2 ohms. Okay. They are telling current coming out is I. So they are asking us what is the current I1 here and what is the current I2 here. This is what they are asking. So this is the question. So let's see how to solve the questions. We'll be using Kirchhoff's law here. First of all, if the current coming out is I, let I1 go here. So what will be the current going here? I minus I1. I can tell current going here is I minus I1. Okay. Now this current I1 is going, out of that I2 is going here. So what is the current going here? I1 minus I2 is the current which is going here. Now this I2 current is going like this, this, it is meeting this current. So this current is again coming, this is I1 minus I2 plus this is coming I2. So this is basically I1. Now this I1 current meets I minus I1 current and becomes I. So basically the total current which was coming out is returned. So this is a complete and it's a correct circuit drawing. So let's use Kirchhoff's law one by one. So if I move like this in Kirchhoff's law, we know that if you are going in the direction of the current, it is taken, the potential is taken as positive. If you are going opposite to the direction of the current, the potential is taken as negative. If you are going in a cell from negative to positive, if you are going from negative to positive, it is taken as minus. And if you are going from the positive to the negative, it is taken as plus. So this is the concept. So let's use it. This is the concept which is there in the chapter, and let's see how we can use it. Okay. So let's find out. So in the part C, D, E, F, we are using Kirchhoff's second law. We are using Kirchhoff's second law. So let's see. Let's start from here. So it is, I'm going in the direction of the current. So 2I2, it will be plus. Then in the direction of the current, 4I2. And then again in the direction of the current, so 2I2. And then here, so we are going opposite to the direction of the current. That is minus 8. I1 minus I2 is 0. Okay. So what are we getting? So this is coming 8I2 and my plus 8I2 minus 8I1 equal to 0. So we are getting 16I2 equal to 8I1. That means we are getting I2 as, we are getting I1 as 2I2. We are getting I1 as 2I2. Okay. Now let's apply in the circuit part B, C, F, G in this part. So if I turn like this, so what can I, let me start from here. So we can write 2I1 because I am moving in the direction of the current. Again, this is in the direction of the current. So 8 I1 minus I2, and again in the direction of the current. So 2I1, and now opposite to the direction of the current, so minus 8I minus I1 should be equal to 0. So let's solve for 2I1 and 8I1 is 10I1, 12I1 and plus 8I1. So 20I1, and similarly minus 8I2 minus 8I is 0. So we know that I1 is 2I2. So I1 means 2I2. That means it becomes 40I2 minus 8I2 minus 8I equal to 0. So 8I should be equal to 32I2. So I will be equal to 4I2. This is we got. Now let us come to the third part of the circuit. Third part of the circuit is this. So if I am going like this, so let's start. I am moving from negative to positive. That is minus 6. And then in the direction of the current, so plus 3I. And then in the direction of the current, so plus 8I minus I1. And then in the direction of the current, that is plus 2I equal to 0. So 3I, it is 11I plus 2I. It is 13I minus 8I1 is equal to 6. Now we know that I is equal to 4I2. Okay, so I1 is 2I2. So let's put here 13I minus I1 is 2I2. So 16I2 equal to 6. So here I means 4I2. So 13 4s are, this is 52. I2 minus 16I2 equal to 6. So 52, so this is 6. 36 I2 is coming 6. So I2 is coming 1 by 6 ampere. So I2 is 1 by 6 ampere. So what is I1? So I1 will be 2I2. So I1 will be, it is 2 into 1 by 6, so 1 by 3 ampere. So if I1 is 1 by 3 ampere and I2 is 1 by 6, so let us put here. So I will be 4I2 and I2 is 1 by 6. So 4 by 6, 2 by 3, it's I2 is 1 by, so 2 by 3 ampere. Okay. So this is how we found the currents I1 and I2 in the circuit. Okay friends. So this is how we are using the Kirchhoff's laws to find the Kirchhoff's laws we are using in the mesh, in the 3 mesh, we are using the Kirchhoff's laws, and see how we are finding out using the 3 different sections. Okay. So let's move on to some few more sums from here. So what I would suggest you is that please watch the video, and in the next video I will be doing few more very interesting sums. So I hope till now you have understood, and you please watch the next video where I will be discussing very, very important and very new tricky type of sums. Okay. So we'll meet again in the next video. Till then, thank you from us, and please subscribe my channel.